Okay, very good afternoon, my dear students. Today we can discuss the properties of entropy. In the previous class, we discussed the concept of entropy and its expression for entropy. And like in module 1, we discussed the concept of information, its equation and its properties. Actually, in the module 1, we discussed that the information is proportional to uncertainty and it's inversely proportional to its probability. That is, information I of E is proportional to U of E uncertainty, and it's proportional to 1 by P of E, that is inversely proportional to P of E. So we and also we defined that total information is a sum of all the individual event informations. And we derived the expression for entropy as I of E is log 1 by P of E base 2. If the base is 2, we define the units as bits, and if the base is like 10, we have defined the units of information as decits, and if the base is E, then we have defined the units as nats. So like that we have defined, in general the units of information are bits only. So information I of E, or that is for a particular event E, is log 1 by P of E, where P of E is probability of E, probability of the particular event. So if you want to take that P of E to the numerator, you can write it as P of E whole power minus 1. So take that minus 1 outside the logarithm. So you will get it as minus log P of E base 2. That is the expression for information. And that is the information for a particular event. For example, if you want to, if you want to get the average information, so the average information content generated by the discrete memoryless source, the average information content generated by a discrete memoryless source is called source entropy. The average information content generated by the discrete memoryless source is called source entropy. Now, for example, here generally it is represented with a variable h. It is the average information content of all the messages. So here let us assume that there are capital M number of messages, and we assumed that the messages are represented as small m1, small m suffix 2, small m suffix 3, like that small m suffix capital M. Here capital M represents that there are that many number of messages. It's the total number of messages. With respect to the probabilities P1, P2, P3 up to so on, P suffix capital M. These are the respective probabilities of the messages, and these are transmitted through the channel. These are transmitted through the channel, where capital M represents the total number of messages. Here capital M represents the total number of messages. Now this P1 is the probability of the message M1. So P2 is individually the probability of individual message M2. So like that P suffix M is the probability of the individual message M suffix capital M. Now, but you know that the sequence is a combination of either the symbols or the messages. Here we have defined like messages. In general, the sequence is a combination of certain number of symbols or messages. Here it is a combination of certain number of messages, and remember that each message is once again a group of some bits. Okay, now here you are defining a sequence of length capital L. Here we are defining the sequence of length capital L, and these m number of messages will be repeated, and we are repeating this capital M number of messages. We are repeating out of the L bit sequence. Okay, now what will be the probability of message M1 out of L number of messages? So we can't tell that the probability be three times or 4 times or 5 times. We don't know, but we know only the probability of the message M1 individually. Okay, so the probability of occurrence of M1 message out of L number of messages is its individual probability P1 multiplied by total length sequence capital L. Then the information content due to the message M1, then the information content due to message M1 is I of M1, which is P1 into L multiplied by log 1 by P1. See, this P1 into P1 into L. P1 into L is the probability of the message M1 out of L number of messages, and this log 1 by P1, is the information, it's the information of message M1. So I think in the module 1, we can recollect the equation of information. Information of message M1 will be log 1 by its individual probability, that is P1. But why we obtained the probability some value P1 into L? This is the probability of occurrence of M1 message out of L number of messages multiplied by its individual information. That will be the information content of message M1 out of L number of messages. Okay. Now similarly, we can calculate, we can tell the information due to message M2 out of L number of messages. So it will be P2 into L multiplied by log 1 by P2, log 1 by P2. Similarly, the information content due to mth message, M suffix capital M, is I of M suffix capital M, which is Pm into L multiplied by log 1 by Pm. Log 1 by Pm is the information of mth message, and Pm into L is the probability of mth message out of L number of messages. See, we have represented individual informations, that is information of M1, information of M2, like that up to information of mth message. But we know that we studied the property of information, that total information content is the sum of information contents due to m number of messages. Information contents due to m number of messages. Therefore, I suffix t is the total information content, which will be the sum of information contents due to individual messages, that is I of M1, I of M2, I of plus up to so on, I of MM. Okay. Now just please substitute the value of I of M1. Okay, so it will be P1 into L, P1 into L. Otherwise, you can write it as individual, its information contents due to individual m number of messages, individual messages. And also you can represent it as individual messages. Just we substituted the values of I of M1, where I of M1 is P1 into L multiplied by log 1 by P1 plus P2 into L multiplied by log 1 by P2 plus so on plus Pm into L multiplied by log 1 by Pm. Here in the series, the common value is capital L, that is the bit length, sequence length. Okay. Now the entropy, you know the definition for entropy as the ratio of total information content to that of the total length of the sequence. So that is IT by L. Okay. So H is equal to IT by L. Now, because here we took L as common, please take L as common and take that L towards the right hand side. Please take L as common towards the right hand side. Then you will get IT as H as IT by H as IT by L. Then also you will get it as, P1 into log 1 by P1 plus P2 into log 1 by P2 plus up to so on Pm into log 1 by Pm. H is equal to IT by L. So this you can write it as a summation series. So this is a summation series. So that's why I have represented it as summation. How many messages are there? Yeah, 1 to M. So that's why we represented it a variable that J is equal to 1 to M. J is equal to 1 to minus summation. J is equal to 1 to M. P suffix J log P suffix J base 2. Log P suffix J base 2. Okay, the units of entropy are, here the units are bits per message. But in general, the units can be either bits per symbol or bits per element. So a bits per any element like that. For example, if the information units are nats, then the units of entropy will be nats per message or nats per symbol or nats per element. Any element. Okay. For example, if I take the element as sample, okay, so it will be bits per sample. Okay, and for example, if the units of information are decits, it will be decits per message or decits per symbol or decits per element. Okay, so now, so please remember this equation. So H is equal to minus summation J is equal to 1 to M Pj log Pj base 2, where Pj represents the probability of jth message and capital M represents the total number of messages. H represents the entropy. J is the variable. J is the variable. Okay. Okay, now I request C3. Ma C3 unnara? C3. C3. This is for attendance. Please respond. C6. C6. C6 ma. Actually, your number is present. C7. 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 D1. Okay, ma, thank you. Can you please tell me the definition for entropy and the expression? Actually, I have shown it in this slide. Just to choose cheppandi chalu. So what is entropy? Please define it and tell me the expression for entropy.
Entropy is defined as the average information content generated by DMS.
DMS అంటే ఏంటి? Discrete memoryless source. Please repeat, no problem.
Digital memory.
Discrete memoryless source.
Discrete memoryless source. H is equal to minus sigma I is equal to 1 to m.
J.
J is equal to 1 to m. Pj dot log into log 2 pj bits by message or bits by symbol or bits by element.
అమ్మా ఇక్కడ మీరు లాగ్ పీజే బేస్ 2 అని కాల్ చేయండి. సో ఎలా దీన్ని యూ షుడ్ రీడ్ ఇట్ యాజ్ హెచ్ ఈజ్ ఈక్వల్ టు మైనస్ సమ్మేషన్ జే రేంజెస్ ఫ్రమ్ 1 to m p suffix j log p suffix j base 2 అనాలి. ఓకే
Okay, ma'am.
Okay, this is the equation for entropy. Can you tell me the equation for information? మనం module 1 లో డిస్కస్ చేసుకున్నాం కదా. So can you tell me the expression for information? Okay, thank you. D3 ma D3 once again C3 came. C3 okay, E1 okay ma, thank you. Can you please define the equation for information?
I of e is equal to minus log p of e.
Very good. So I of e is equal to minus log p of e or log 1 by p of e. What is the base of logarithm?
It can be 2 or 10 or e.
Okay, what are the units of information?
Bits or nats or decits.
Very good. So actually your friend defined the entropy here. What is entropy? Once again you please define it.
Average information content generated by a discrete memoryless source.
What is discrete memoryless source? Discrete and endukantunaru actually ga this is not a continuous information. Okay, because it is in the form of bits. So each bit will have different probability. Okay, so andukani discrete and call chestunaru. Memoryless అని ఎందుకు చెప్తున్నారు? This is discrete memoryless source. So memoryless అని ఎందుకు అంటున్నారంటే here the message M1 does not rely on the information of M2. So alane message M2 does not rely on message mth message. So all are independent to each other. Like present sample does not depends on past information. So that's why it is called as memoryless source. So discrete memoryless source. Okay ma. Can you tell me the expression for entropy?
H equal to minus sigma j equal to 1 to m pj into log to the base 2 pj.
Okay. What is pj? Probability of
event j.
Event message ఈవెంట్ అంటే మొత్తం అంతా కాంబినేషన్ ఆఫ్ సర్టెన్ నెంబర్ ఆఫ్ సింబల్స్ ఆర్ మొత్తం. బట్ ఇక్కడ మనం ఇండివిజువల్ మెసేజ్ కదా, P1 ఆర్ P2 ఆర్ P3 అప్ టు సో ఆన్ PM. సో PJ is the probability of jth message. Capital M, what is capital M?
Number of messages repeated.
Okay, total number of messages. Okay, very good. Thank you. Now here we can start the properties of entropy. Now I want your friends to read it out, because every time I am speaking and you are listening. Just you read it, then I will explain. C3. మా మీరు రెస్పాండ్ అవ్వాలి. C3 C6 please respond. C6 C6 just you can read the statement shown here, that's enough. C6 okay, G5 okay, thank you very much. Please read the statement shown here. Now, is it Navneet?
If a data stream consists.
Yes,
ma'am.
Okay, continue.
If a data stream consists of a single message with a maximum probability P1 equal to 1, since sum of all messages probability of an event equal to 1, then the entropy is 0.
Entropy is 0. Okay, very good. So if a data yes, if a data stream consists of single message, that is I told you and as an example of m number of messages, but here in this data stream it consists of only one message. Okay, and if you are having only one message with maximum probability, what is the maximum probability of an event? Sum of all message probabilities of an event is generally equal to 1. That is the total probability. A message probability sum should be equal to 1. But here how many message probabilities are there? Messages are there. Only one message. Then its probability should be equal to 1. Then our entropy is 0. This is the first property. Okay, please listen this carefully. From definition of entropy, H is equal to minus summation j is equal to 1 to capital M P suffix j log P suffix j base 2 bits per message. Okay, Navneet, please tell me what is the value of capital M here in this example, in this first property. What is the value of capital M? Navneet.
Yes, ma'am.
What is the value of capital M here?
1.
1. Very good. So here capital M value is 1 because the data stream consists of only one message, single message. So M is 1. So in this series, we like only one message is present. So let us take that first message as first message probability as P1. Then it will be minus P1 log P1 base 2. Now what is the value of P1? Navneet, what is the value of P1?
1.
1. So P1 value is 1. So that's why minus 1 log 1 base 2. What is the value of log 1?
0.314.
What is the value of log 1 base 2?
0.31.
Log 1 ma. Check it, no problem. Go through calculator. One log, how much? Log 1 value is Navneet? Log 1. 0.
0.
Okay. 0. So entropy is 0. Okay. So our entropy value is 0 if a data stream consists of only one message with its maximum probability as 1, then our entropy value is 0. That is the first property. Okay. Thank you. Thank you, Ma. Next, some other student, please read the second property. Other student who will read, please raise your hand. E0, E0. Okay, Ma. Anushka, H2.
Ma'am.
Okay, thank you. Can you please read the second property of entropy?
Yes, ma'am. If a data stream consists of multiple messages, but out of them, if only one message have the maximum probability equal to 1 and the other messages probabilities are 0, since sum of all messages probability of event is equal to 1, then the entropy is 0.
Okay. So, okay, thank you. If a data stream consists of multiple messages, okay, for example, the messages be M, but out of all the messages, only one message possesses maximum probability. So what is the maximum probability? It's 1. So other probabilities must be 0 because the sum of all message probabilities of an event is 1. So that's why if a particular message has maximum probability equal to 1, the other message probabilities will be 0. Then also our entropy will be is 0. So we can prove that by taking the definition of entropy. So from the definition of entropy, H equal to minus summation j is equal to 1 to m p suffix j log p suffix j base 2. Now how many messages are there? How many, Anushka, how many messages are there?
M, ma'am, capital M.
For example, we are assuming capital M messages. But like what can be, for example, if P1 has a maximum probability, then it will be 1 log 1 base 2 and other probabilities are 0. So minus 0 log 0 base 2. Cheppandi.
0 log 0 to the base 2.
Okay.
Same next 0 log to the base 2.
Ala continue up to m number of messages.
Yes,
So actually 0 multiplied by any value gives you 0 and log 1 multiplied by any value gives you 0. So that's why entropy of this particular data stream will be 0. So if a data stream consists of multiple messages, but out of all the messages, if only one message have maximum probability and other probabilities are 0, then our entropy will be 0. So can you read the first two properties, Anushka?
Yes, ma'am. First property is if the data stream consists of only single message with a maximum probability P1 is equal to 0, then the entropy will be 0.
P1
Since this
1. P1 is 1.
Yes, ma'am.
Okay.
Then the entropy will be 0.
Second property?
If a data stream consists of multiple messages, but out of them if only one message have the maximum probability which is equal to 1 and the other messages probabilities are 0, then the entropy will be 0.
Entropy will be 0. Okay, very good, very good. So actually you can, otherwise you can represent this statement at the end. So this is just for your information, okay? Like this you can keep. This is actually not the statement. This is just for the information I mentioned here. Okay. Now, who will read the third property? Please raise your hand. Who will read? H1, H1.
Yes, ma'am. Yes, ma'am.
Okay, okay. Please read. Okay, please read the third property.
Entropy of a particular event is always greater than zero. Therefore, minimum entropy of an event is equal to zero.
Okay, entropy of a particular event is always greater than zero. So, what is the minimum entropy of an event? It is zero. So, H of E is always greater than or equal to zero. Actually, in the first and second properties, we discussed the case where entropy is zero. So, that comes under H of E equal to zero condition, but it is always greater than or equal to zero. Okay, you only read the fourth property. I request H1 to please
Yes,
read the
yes.
fourth property.
Let us consider a binary symbol having two messages M1 and M2 with their respective probabilities as P1 and P2. Then the entropy H is equal to P1
Okay, please
log
wait.
1 by.
Please wait. Uh, Let us consider a binary symbol having two messages, M1, M2 with their respective probabilities as P1 and P2. Now, can you please tell me the expression for entropy? The
H
general
is equal
expression
to
for
minus summation of j equal to 1 to m pj into log pj
Pj base 2.
is
Now what is the value of capital M in this case?
2, ma'am.
Yes, very good. So here capital M value is 2. So H will be P1 log 1 by P1 plus P2 log 1 by P2. So to represent P1 and P2 in the numerators of logarithm, you can take minus outside the logarithm. So what is the total entropy in this case? Please read this equation.
H is equal to minus p1 log p1 base 2 minus p2 log p2 base 2.
Okay. Now, what is the sum of all message probabilities of an event?
1, ma'am.
1. So, here P1, two messages are there. So, sum of probabilities of P1 and P2 should be equal to 1. So, P1 plus P2 is equal to 1. Now, let us please assume P1 as some P. Please assume, let us replace P1 and P2 in same variable. So, let us assume P1 as some P. Then P2 will be how much?
1 minus p, ma'am.
Yes, if you take P1 as P, then P2 will be, take this P to the right hand side. So it will be 1 minus P because P1 plus P2 is 1. Now please substitute these values in the expression of entropy, in the above expression of entropy H. Then how you will get? Please tell me the expression. If you replace P1 as P, otherwise you can see here. If you replace P1 as P, and P2 as 1 minus P, then entropy will be
H is equal to p into log 1 by p base 2 plus 1 minus p into log 1 by 1 minus p to the base 2.
okay. Uh, Once again, read the second statement, second equation.
H is equal to minus p log p base 2 plus 1 minus p log 1 minus p base 2.
Actually, you will get negative term for both the negative sign for both the terms. So just we took negative sign as common from these two terms. Okay, thank you. So here in this case, what we did, here we considered like a particular event consists of two messages, M1 and M2 with their respective probabilities as P1 and P2. then its entropy will be P1 log 1 by P1 plus P2 log 1 by P2. You can see here. What we did here, we assumed a binary symbol consisting of two messages M1, M2 with their respective probabilities as P1 and P2. Then entropy will be minus P1 log P1. This P1 we took in the numerator. So you will get minus P1 log P1 base 2 and P2 log P2 base 2. Now here we know that the sum of two probabilities of the event is 1 because this event consists of only two messages. So P1 plus P2 is 1. To represent it with the same variable, just consider P1 as P and P2 will be 1 minus P. Now just please substitute the values of P1 and 1 minus like P1 and P2 in the above expression. Then you will get H as P log 1 by P base 2 plus 1 minus P log 1 by 1 minus P base 2. Okay, this 1 by P, so if you want to write it as P, then P power minus 1. So for both the terms you will get negative sign. So entropy of an event consisting of two messages will be H is minus of P log P base 2 plus 1 minus P log 1 minus P base 2. Okay, remember this equation. Now here please observe the fifth property carefully. Maximum entropy of the event with the two equally likely messages is 1. What is meant by equally likely condition? So in the case of equally likely situation, the probabilities of the message probabilities of an event are equal. Okay, the message probabilities of an event are equal, then that event is considered to be in equally likely condition. Okay, for equally likely messages, their message probabilities are equal or same. This fifth property is the extension of fourth property. In the fourth property, we assumed it a condition of a symbol having two messages. So in the fifth property is the extension, but for that consider same like two messages of the event and two messages have the probability of P1 and P2. But here what is the assumption? The messages are equally likely. So because the messages are equally likely, then its probabilities, the respective probabilities should be equal. So you can show that for equally likely messages, their message probabilities are same. That is P1 is equal to P2. And here we have assumed that both are equal and it is same to that of P. And it is equal to that of P. But you know that the sum of probabilities of an event is equal to 1. The sum of probabilities of an event equal to 1. So P1 plus P2 will be equal to 1. So P1 plus P2 will be 1. Now, but what is P1? For equally likely conditions, P1 is equal to P2 and we assumed it as P. So please replace P1 and P2 with its respective value, that is P. So upon substituting, you will get P plus P as 1 and 2P will be 1 and P is 1 by 2 and P is 1 by 2, that is 0.5. That is 0.5. So what is the thing that you should know here? The maximum entropy of the event with two equally likely messages is 1 and it occurs at the probability 1 by 2. It occurs at P is equal to 1 by 2. If you want to represent the characteristics of entropy and the property like probability, okay, so two properties. So this fifth property is the extension of fourth property. So maximum entropy of an event with two equally likely messages is 1 and it occurs at P is equal to 1 by 2. Please observe the characteristics shown here. This characteristics is a relationship between the entropy and the probability. So you will get maximum entropy. So what is the maximum entropy in this case? 1. So maximum entropy for two equally likely messages is 1. That occurs at p is equal to 1 by 2. So even if you reduce the value of p like below 1 by 2, or even if you increase the p value like greater than 1 by 2, then our entropy will reduce. So the maximum entropy of the event with two equally likely messages is 1, and it occurs at p is equal to 1 by 2, and it occurs at probability equal to 1 by 2, that is 0.5. Now please, you know the expression for entropy. What is the general expression for entropy? H is minus summation j is equal to 1 to m p suffix j log p suffix j base 2. Okay, so here p1 and p2 both are same, and you got the value, you obtained the value of p as 0.5. You obtain the value of p as half or 0.5. So it will be 0.5, that is p1 log p1 base 2 plus p2 log p2 base 2, because there are two messages. So minus of, but what is the value of p1 or p2? It is same as p, and we obtained p as 0.5. So that's why we directly substituted as 0.5 log 0.5 base 2 plus p2. p2 is once again 0.5 log 0.5 base 2. Okay, so it is equal to, so it is a sum of two equal terms. So it will be how much? 0.5 plus 0.5, you will get it as 1. So log 0.2 log 0.5 base 2. So you know that log a base 2 can be represented as log a by log 2. Log a by log 2. Okay, so some other student, please calculate the value of log 0.5 by log 2. See what is the obtained value?
-1.
Minus 1. So log 0.5 divided by log 2 is minus 1. So minus of minus 1, it will be 1. Okay, now I request you to please read the fifth property. Okay, H4.
Ma'am,
Oh, thank you very much. Please read the fifth property.
maximum entropy of the event with two equally likely messages is 1. For equally likely messages, their message probabilities are same. That is, P1 is equal to P2 is equal to P. But P1 plus P2 equal to 1, ma'am.
Endukani, why P1 plus P2 is 1?
The probability of the message is equal to 1, ma'am.
Sum of probabilities of an event is 1. In this event, we considered only two messages. So that's why the sum of probabilities of the two messages is 1. So P1 plus P2 is 1. Okay, good. Continue.
Therefore, P equal to 1 by 2, that is equal to 0.5.
That's equal to 0.5.
H is equal to minus of 0.5 log 0.5.
Okay, ma. Okay, please wait. Can you please tell me the general expression for entropy? Please remember this equation. That's why I'm asking so many times.
Yes, ma'am. Entropy H is equal to minus of sigma j equal to 1 to m log pj to the base 2.
Pj log Pj base 2. Pj is the probability of jth message. But here there are only two messages. So the two messages probability will be P1 and P2. So P1 log P1 base 2 plus P2 log P2 base 2. So negative sign is common for both the terms. So that's why we took negative as common. So minus log 0.5 base 2. So how much you obtained?
1 ma'am. Entropy H equal to 1.
Okay. Now please define the fifth property. మీరు define చేసేటప్పుడు ఇట్లా రాయకూడదు. ఎలా define చేస్తారు? Maximum entropy of the event with two equally likely messages is 1 and that occurs at probability p is equal to 1 by 2. Actually I have shown it with red color. So that is the fifth property, maximum entropy, and the proof for this is the thing shown in black color. So maximum entropy of the event with two equally likely messages is 1 and that occurs at p is equal to 1 by 2. So you can analyze the same by using the characteristic shown here. Okay, ma, thank you very much.
Yes, ma'am.
So in this characteristics, if you see, Hmax is represented in terms of like with respect to the probability. So what is the maximum entropy of this event? For two equally likely messages, it is 1. So that's why I mentioned Hmax as 1. Okay, and that occurs at p is equal to 1 by 2. If the same, please extend towards the x-axis. So at p is equal to 1 by 2, Hmax is 1. Okay, and if you increase the value of p, that is if you make p value as greater than 1 by 2 or p value if you take it as less than 1 by 2, you check the case, no problem. Adoksaరి meer check cheyandi. If you take p value greater than 1 by 2 or p value less than 1 by 2, okay, that won't comes under the fifth property because the two messages probabilities are not same. సో మీరు ఇప్పుడు p గ్రేటర్ దెన్ 1 by 2 తీసుకున్నారు అనుకోండి, సో హౌ విల్ బి లైక్ 0.6 తీసుకున్నారు. సో 0.6 plus 0.4 will be equal to 1. So this won't comes under equally likely condition. Okay, so for two equally likely messages, maximum entropy of the event is 1 and occurs at p is equal to 1 by 2. So next property is the same property that what we studied in the fifth property, but that extension for m number of messages. So maximum property of m equally likely messages. Okay, anyhow almost all time up. So we can revise the first 5 properties because this is a lengthy property, somewhat we have to derive. So tomorrow we can continue the sixth property and some of the problems, and we can continue with the module 3. Lateral entry 420.
Ma'am.
Okay, so can you please define entropy, its equation and the 5 properties studied? Just I will show you the PPT, accordingly you tell me. Define entropy, its equation and its 5 properties you studied today. Please tell me.
The average information content generated by a discrete memory less, ma'am.
Okay. Its equation.
Equation h is equal to minus summation of j is equal to 1 to m pj log pj to the base 2.
What are the units of entropy?
Bits per message, ma'am, or bits per symbol or bits per element, ma'am.
Okay. What is p suffix j?
Probability of a message, ma'am.
A message, the jth message. Okay. Capital M is the number of messages, total number of messages of the event. Okay, properties cheppema. Okay, tell me the 5 properties what we studied in the today's class.
If a data stream consists of single message with the maximum probability p1 is equal to 1, then entropy is 0.
Okay. Okay, very good. Tell me the second property.
If a data stream consists of multiple messages, but out of them, if and though one message have maximum probability equal to 1, and the other messages probability are 0, then entropy is 0.
Okay. So actually, you should prove that. So in exams, whenever you get like, please explain the properties of entropy, you should write its statement and you should prove it. Okay. Next, third property. What is the third property?
Entropy of a particular event is always greater than 0.
Okay.
Therefore, minimum entropy of an event is equal to 0.
Okay.
H
H of E
Fourth
is
property.
always greater than or equal to 0.
Zero.
Okay. What? Tell me the fourth property.
Let us consider a binary symbol having two messages M1 and M2 with their respective probabilities as P1 and P2. Then entropy H is
Minus
equal to
P1.
minus P1 log P1 to the base 2 minus P2 log P2 to the base 2.
If you replace P1 as P, P2 will be 1 minus P because sum of probabilities is equal to 1. So then what is the expression? H is?
H is equal to minus P into log P to the base 2 plus 1 minus P log 1 minus P to the base 2, ma'am.
So negative is common for both the terms. Please tell me the fifth property.
Maximum entropy of an event with two equally likely messages is 1, ma'am.
And that occurs at?
Equally.
Ma'am?
Ma'am?
See, maximum entropy of the event with two equally likely messages is 1. And that occurs at capital P equal to 1 by 2. Okay. So, can you please explain the graph shown here?
Ma'am, PPT is not visible, ma'am.
Okay. Okay, the graph represents the maximum entropy with respect to its probability. So maximum entropy for two equally likely messages is 1 and that occurs at P is equal to 1 by 2. It is a characteristics that shown a relationship between H max and the probability of the event. Okay, so whenever P is 1 by 2, then maximum entropy you will get for the two message condition that is equal to 1. So if you go like P greater than 1 by 2 or less than 1 by 2, the entropy will reduce. So maximum entropy is 1 and that occur at 1 by 2. Okay. Okay, ma. Thank you, Manohar. Thank you. So tomorrow we can continue with the sixth property and some of the problems we can discuss here. Okay, I took attendance. You can leave the class.